So my name is Sasha. I work at MailGun. So to give you a little bit of context, um, what MailGun is, not everyone knows what MailGun is. So MailGun is a email service which is scalable. So think about us as postfix. So we think about ourselves, not as senders or just receivers. So we build a scalable email service for the next generation. And everything that we do, we try to make email cool protocol again. So that's kind of our motto, right? Sorry? Mail hooks? Oh, sorry, no, probably not. Um, here I'm going to explain. First of all, before I even start this talk, I'd like to say thank you to everyone on the Docker IRC channel. When you first start to use new technology, usually you dump into IRC and start asking a bunch of stupid questions. So, and your very first experience depends on how responsive people are answering your stupid questions. And you guys were awesome. So that was one of the main reasons I actually started diving in and researching what Docker is. Very responsive. Thank you so much, guys. You do a really great job. So, started by Rackspace a year ago, and to give you the context, why do we think to use Docker and using Docker and really investing our time to Docker from being a part of Rackspace and being a Rackspace project, not only being like a standalone project, and what our thinking like very not like kind of hack something cool, but really kind of strategic thinking for a MailGun project to use Docker in the longer term. So here's our profile. We're not the biggest project in the world, but we're still pretty big. So we have more than 100 servers, which is 30% of them are cloud, 70% of them are dedicated boxes that are reserved to us. That's the cool part of being Rackspace, right? You can have a lot of dedicated boxes. We actually embrace Rackspace hybrid approach and use dedicated whenever it makes sense. So it really makes sense for us to use dedicated for databases that do a lot of stuff, or for processes that do a lot of CPU-intensive tasks, and we don't really want to share that, or a lot of network-busy stuff. So we kind of think like if you can use dedicated, you should do that. So we do that as well. So we have a lot of dedicated gear. And actually, it's cool to have dozens of those cool boxes that are beautiful. Once you get the screenshots from our DC, we're like, oh my gosh, or they're all shiny, standing there, and all yours, which is actually pretty cool. And so, in the moment of truth for us, when we became part of Rackspace, we had 6 busy cloud boxes. It's kind of anecdotal evidence, but then we just put 2 R720s, and they just did nothing, very relaxed, the same stuff with our cloud boxes, because we had no like noisy neighbors in there, never, or like for these dedicated boxes. But it's like, oh my God! And the pricing was like the price match. If you want to know the real numbers, I can share you like later. But that was actually very cool. Just replace 6 servers with 2 that do basically nothing. Yeah, that's why we love dedicated. And like, who needs cloud when you have these boxes? I'm just kidding. Cloud is cool. We love it. So, so we ended up using cloud as an immediate scaling growth layer. So we have spikes in usage. We immediately use cloud boxes, and once we figure out that this is not just a random spike or just just an increase in usage, we just request new dedicated boxes and switch the load that is extra load to the dedicated boxes. That's how we do money saving, because cloud is dedicated is less expensive in the longer term, right? That's how we do our planning. So that's what I just said. So here are the problems we have. We really have a lot of different workers, right? The process of different types. We have API, jobs, analytics, like crunching, like mail list expansion process, spam filtering process. There are just 15 types of them, and we have like 300, more than 300. I just counted in my notebook really quick, running instances at any given time. We really love a lot of databases, so we're kind of a little bit fanboys of all databases. So we have 5 types of different databases and 50 plus running database instances, right? So to sound more serious, we kind of use the right database for the but we have actually staging environment that actually reflects our production environment, so we can do all this stuff in there. That complicates things a lot. And development environment is also very complex because of that amount of different processes and stuff. We actually fight these complexities already, so we're not like using a bunch of shell scripts. We use Chef and Vagrant very aggressively. So first of all, we really like them. It's not like we have some problems, huge problems with them. No, but we actually have some. complexity. We have 72 custom cookbooks that we wrote ourselves and 36 different roles. And like chef is cool, and the chef concept is extremely like sharp in terms of it maintains invariant. When chef comes to server, it knows that it doesn't break stuff, right? That's the core concept of chef. That's why it's better than the just your shell script that you wrote yesterday, right? But at the same time, chef is no master. It doesn't own the server configuration files. That's why you end up constantly asking, oh, is this file exists already? Anyone wrote it? Did you do something with it? Can I really touch it? You know, all that stuff. Yeah, so this is like questions and worries. How do I don't break my production database right now, rolling out? We do chef on every deployment. So we do chef and deploy. So we really care about actually, you know, we're checking out Cassandra as well to test your new driver that you just wrote for it, or like hacked open source Python driver is not fun, right? Because your laptop probably won't. So what, like my dream is have exactly the same development, staging, and production, which I code in, which I deploy without any differences. We do up to 10 deployments per day in a production system without shutting down the server, without maintenance. So we need really fast deployments. Up to, I mean, it's not like we deploy up to like 10 times every day. Sometimes we deploy twice, sometimes we deploy 5 on a really busy day. It depends on the features that we're rolling out. And actually, being a part of Rackspace, having the access to all these dedicated gear, we really want to get 100% advantage of all the bare metal boxes that we have. We are not willing to overpay for cloud overhead. And actually, cloud, on all, we've checked all the different clouds. We've been using SoftLayer before acquisition. We've been using Amazon. We are actually using right now Rackspace. And all of them have their own set of problems with networking, like with busy neighbors, all that stuff. So we don't really, with hypervisors, we don't really willing to pay if we already have a right solution for us, which is dedicated gear, right? So, but we really like the idea of using the same images on dedicated cloud service without the need to spin up a VPS on your dedicated box and just for the sake of using the same image. So that leads us to like conclusion. What Docker gives us in this, we can use exactly the same, like the stuff that hit me really, I can use exactly the same container in my laptop, on my staging environment, and on my production, like without any differences. The process that is crunching the stuff on my laptop, I'm pushing the same container to my staging, to production, just attaching new code. It is the same. It's a perfect guarantee. Layers, which is a revolutionary part, in my opinion, what Docker really like changed. What was before you, thanks to layers. So you don't need to alter any files. You don't need to change stuff to fear to breaking any configuration. If you use Docker right, you give that kind of, you're giving that kind of flexibility and power. So that's what I've said. Nothing is ever altered, always added. And yeah, I think this is pretty debatable, but I think that there's literally like no VM overhead, and we can use 100% of bare metal superpower that we have. And I think there's some overhead in some cases, but we can discuss this later, or you can tell me, because I'm really not the hugest expert in that field. So actually, we love the API for orchestration, building our dev stage and prod chain. So that is suited for us, for a MailGun project that cannot switch to Heroku, that cannot switch to .cloud, because we already are the cloud, which is very specialized, but still, right? So that's what I said. We now have our own Heroku on our own dedicated hardware that does exactly what we need without using any other PAS. So this is my second part, which is more practical. It's about how we are using Docker, how did we start using Docker, and some gotchas with the Docker that we figured out and may be helpful. To be fair, like 90% of these gotchas were fixed by the recent Get Docker release, which is 0.50. But there are still some open questions left. I just want to share with you guys so we can discuss them probably. So this is I really like the Docker build, right? So there's a nice sample from the docs that you can get. So I thought, okay, so this looks really cool. Let me try, replace all my chef scripts in it, and this is how the reality looks like. It's a little bit different, and unfortunately, I cannot scroll down. It just wants like 20% of what I have just for one image. So okay, so what is the solution? Of course, the first promoted solution. You already use Chef, so just use Chef Solo, right? But there are some problems with that. So the first one, it's really cool to upload the Chef Solo scripts and like your cookbooks before actually using that. But that your layers are gone once. I'm not sure if fixing 0.50, but once you add command, it actually doesn't use anything that goes after that. You just restart it every time after every single add command. And once you launched Chef Solo, this is run command, actually one commit, as far as I understand. Maybe I'm wrong, but from what I've noticed, it's one layer. If something is broken in there, the Chef script, like that is doing like all 72 cookbooks or like 50 cookbooks, something goes wrong, you have to redo it from scratch again. You know, Salmon, and he's got because he wrote it, they wrote it this way, but you can embrace layers and images really, and you can have like different layers of different images used for different purposes. So you can have your base image that contains the base stuff that you really need in every box, let's face it. So I use aptitude, I use pseudo, I use all that stuff, right? I use like netcat, I use iftop, I use all that things, right? So I just need that. Then you go up to authentication image, which really creates your users that you need. And then next, all right, you can figure it out. You can use Python image, right? So you combine all these images and stack them to create really fast deployment scenarios. So that's how you manipulating these images. You can save a lot of your time not repeating the same steps. And if something goes wrong, you just basically need to restart your thin layer. So you start with a thick layer that does base stuff, and then you change the stuff in your layers, and your base images shrink. So that really works. I like this idea. So what are the gotchas with the Docker build? I already told about this one. This is really something that probably Docker guys should fix, or maybe I should put in pull request once I'm too frustrated with that. So you really want this command to be the last one, but to be fair, you really want this command to be the first one, because this is where you put in your configuration files to the rest of your Docker build. What is a possible solution? I haven't tried it really, but one of the possible solutions is to launch something and do wget of your scripts, but it doesn't really look cool. So the next stuff that hit me, this looks really great. That's why I wrote it this way in the first attempt, like line by line. But essentially, it gives you layer by layer, and I hit the limit of layers because I had really a long list of aptitude stuff. So instead of that, you should probably combine or like as many steps as you can, which are simple and similar to one line, so you can get layers and control over them for every build of the step. So next is using Docker as a dev environment. So I've tried, okay, I can show it maybe in the end of the presentation. So I launched my Emacs, which is my operating system, but not the best, editor in the world. And I opened my terminal, type in no tests, whatever. I thought, okay, what if I just, instead of the terminal with the shell, I launch in my Docker container, which is my environment and does exactly what I need for every project that I need. That would be my perfect environment. And actually, that works pretty fine. So it's easy to achieve that. So you have your container, which does what you need. In my case, it's my ngbox, right? And I mounted volume to my. That was impossible prior, without any hex, without like using hex prior the latest release. But now it's possible. So you can just use mount volumes, and you can mount your local volume to your container, which will, and changes that you're doing in your Emacs or editor will be reflected immediately. So, and it will be there. Actually, the changes are kind of mirrored, but you can use this environment is very different, right? It has your own user. Like we have different user from our laptop. We have different tools of libraries. So it's very cool, and you can spin up and orchestrate these environments really quick because Docker is really quick, right? It doesn't launch VMs or consume memory, so you can shut down whatever environments you have, and I will show if it doesn't break on my laptop after the presentation, after this part. In Emacs, well, there's like NC term, which does a very simple thing. Instead of launching the term, you basically say, hey, launch my Docker container and give me access to it. Feels really cool. Instead of having consoles and virtual environments, you can just have your environments, which are exactly what you need, always fresh, always new. You can do whatever you want inside. Shut it down. Oh, so cool. Yeah. So there are missing parts. I had to orchestrate my environments. I had to write it pretty, comment it out, like remove most of it to understand, oh, so for this environment, I need these images, right? Postgres, Mongo, Redis, React. Are they running? If they're not, I need to spin them up, right? Yeah, if they're running already, I don't need to do anything. They're already running. Then I'm launching my images. Then I'm mapping the ports to my configuration files in my source, like and IPs that are new IPs, which is like sounds like something that can be automated, and like sounds like an open source plugin to Docker that can really build Docker-specific development environments that has images in mind, like Docker containers in mind, right? So you can say, oh, this is my dev env. I need the following tags, images with the following tags launched, and in your like code, make sure that they're running, and then you spin them up, shut them down. So yeah, it sounds like the Python file that I wrote sounds like everyone needs if you use it as a dev env. Yeah, so it's like a tool set to orchestrate environments. So some parts of Docker is a production environment. I run a lot of tests to see how, like we have a lot of services that handle a lot of connections, to do a lot of CPU stuff, so they're all different. I've just, as every developer, I didn't dig into implementation. I just wrote a bunch of different scripts to see, oh, are the Docker containers, really can handle a lot of connections, right? Is there any performance implications or anything like that? Can they do CPU-intensive tasks? Everyone on the IRC channel says that, yeah, you can do that. So but I don't trust anyone, so I just run that. I didn't find any except like a couple. This one, oh, this is the cool part. So the same can be. Sorry, I missed change the slides a little bit. So the cool part of it, that my environment that is running on my laptop, I push the same container to the production and launch my scripts that have just been coded 5 minutes ago on my production or my staging. It's a perfect 100% guarantee that you get exactly the same environment, which that simplifies your life. So there is a gotcha, right? So some kernel settings still have to be set on the host OS. So you really have to be in control of your host OS up to this moment. If you, for example, do set up how you track connections, how do you manage firewalls, how do you, what are your TCP settings on your kernel. So some of them should still be handled on the host OS, so you should have access to that. Well, it's not a big deal for us as we have this access, but it can be something to keep in mind if you're like running services that accept a lot of connections and do a lot of networking stuff. Again, I have one box that has 18 Docker containers running, which are my instances of my workers, right? In Python, you have to do that to kind of get all the advantages of multi-CPU architecture. And it will be in Upstart, what we do right now, we just create a broadcast message and shut down all the workers of the same group. And Upstart kind of waits till they shut down. If they disobey for 60 seconds, it just kills them, right? Like first it sends sick term, then it sends sick kill. So it should be something really cool if Docker or something can do the same. Just wait on all of them for 60 seconds. If they don't respond or if they don't die, there's an Upstart for that. Oh, sorry, this is Supervisor D for that, but it has bugs. I can talk about them later, but we had to move. So something like that would be really cool. And like, what if you really don't have foreground process? You can kind of fix that right now. Creating shell script that do launch React and just waits forever, does nothing. But at the same time, it would be something cool to have something like Upstart that expects process to be forked, can match the process and just hang on it, wait on it. That would be really helpful. Actually, Upstart is not very helpful because it can only count forks for you, but something you can probably match your process by name or any other arbitrary parameter and wait for it. That would be really cool. So like expect fork like as an Upstart, but on steroids. Oh, just to give some context, Upstart is a job manager, which is event-based, which is written for Ubuntu, which we use a lot right now. And there is also some subtle problems. Some Docker scripts really need to set up my database, for example, in Postgres. And for some databases, you can really do that, but sometimes can be really tricky like that. So you actually, for example, if you had to set up your database in your Docker container, like for test purposes, for example, right? You have to do stuff like that. So you have to run Postgres in single mode, and then you have to do. I actually forgot what this Postgres shell means already, but I just was looking in the internet to how do, and then you pass your SQL script to this gigantic piece of code, which is not very intuitive. Something, maybe there can be some workaround to start your Docker container, do some commands like and then commit it in the Docker file. That would be really helpful. So thank you, and I will try to show you if it doesn't break. And the state, where are we at, right, at MailGun with Docker? It's a really important question. So Docker already conquered our development environment in the laptops. We do everything in Docker. It does make more sense for me to launch top-rate Docker containers. We are pushing Docker to as our staging environment. We hadn't pushed the Docker to ours. We haven't flipped the switch to Docker as our production environment yet. So, but we are on the way. So let me show you real quick. So here's my Emacs. Works. So this is my Docker container, and I changed my code, and it looks to me, and I have the separate command, which is another binding, which is just shell. Oh, just hang for some. Oh, okay. So yeah. So basically, for me, it's no difference anymore, right? Before that, I was launching my NC term and my Emacs. Now I'm launching my containers, which here you can see some difference between this is my Python script, launch py working. It launches images, it launches, it launches containers that I need, seeing, do I need to launch it? So it's slightly different, but still gives you the same level of flexibility, which is awesome. Thank you, guys. All right. Do you have any questions? Maybe suggestions, because I won't pretend that I'm an expert in Docker or whatever. So if you have something to share, tell me.
So one particular suggestion you mentioned about Docker not being able to run a different command. So in a Docker file, if you use CMD, if I remember correctly, it'll actually run whatever you specify when you start it up. So that way you don't have to pass in that long line.
Okay.
So that might be a change you can do to simplify that last use case.
Right. Okay.
Do you benchmark database performance?
At this stage, I use stuff whenever it makes sense. For databases, it doesn't actually make sense for me to have it running in Docker containers yet, because usually I change databases once, like configurations once every 4 months, maybe 5 months. I'm changing my configurations for running processes maybe once a month, and I'm changing code every day. So I haven't launched my Postgres or whatever instances in production and didn't benchmark them yet.
I have a tool that you were looking for to launch multiple containers in a dev environment. I think it's called Maestro.
Awesome. Yeah. Cool.
How do you deploy multiple machines in production? Is the machine the same?
Okay, so there's a quick question. From what I noticed from our workflow, as long as we set up a set of packages that our Python processes use, we don't ever change them that frequently. Like I said, maybe once per month. So it makes total sense to push an image to your set of workers, like to push a container, and just launch the same container. And when you're launching container, just tell it where the sources are. As long as that helps you not to push your containers, which can be pretty big, right, themselves, and just check out the code and spin them up. As long as you need to change the actual configuration, you actually need to push the containers, and that takes more time. But that's done not that frequently, right, because your containers are changing not that fast. So that's how you achieve simultaneous deployments. So basically you have host containers waiting for your code to shut down the old ones, put in sources, spin up the new ones. As long as you need to change the container, you just push the new container, and that's it. And then you do the same.
You write scripts to coordinate.
Yeah. So it's Fabric. We use Fabric for that.
For your dev environment, I don't know much about Python development, but is like using a debugger with a remote like Python, is that complicated? Does it work? Do people even do that kind of stuff?
Well, with Python, you can use IDB, right? So you can just set a breakpoint, spin it up, and you're still in the same container, and you're debugging. And I personally don't debug Python processes that much every day, so it's like happens really rarely for us. We're not in debugging camp a lot, so but it's possible when you really need that. When you really need, like, sometimes you're hunting memory leaks, you can still do that, right? You can attach actual, I think you can attach GDB to running Python container, which is just a process. I haven't tried it though. Maybe it will be a cool hack. Thanks, guys. All right, thank you.